Okay, I'm going to respond to your plea for help here with a quick video. Here's the point -6, 12 in the coordinate plane. When you're asked to find the 6-trig ratios related to that point, you're actually rotating from the positive x-axis in the counterclockwise direction. So you're actually finding the 6-trig ratios of angle theta. This angle beta here is called the reference angle, and that's actually what you would take the 6-trig ratios for to answer the question. But since you already know the lengths of all the sides, you don't need to actually know what angle beta is. So the sine of theta, well, this gray triangle is the reference triangle. And if we didn't have a coordinate plane, we would just say, oh, it's a 6, 12 are the legs, and 6 radical 5 is the hypotenuse. And then we would take the sine of this angle would be 12 over 6 radical 5. But since we're in the coordinate plane, we're going to assign this segment right here, this leg, a -6. Maybe you've heard the phrase in your trig class, all students take calculus. What that tells you is the quadrants where the trig ratios are positive. So in the second quadrant, the sine is positive along with its reciprocal, which is cosecant. All the other trig functions in the second quadrant are negative. Okay, so the sine of theta is opposite over hypotenuse, 12 over 6 radical 5. If you reduce 6 into 12 and then rationalize by multiplying top and bottom by radical 5, there's the trig ratio for the point -6, 12, the sine of whatever angle this is, which we don't really know it. Similarly, the cosine is adjacent over hypotenuse. That's why we have a -6 on top, because we're in the second quadrant. That's why the cosine is negative in the second quadrant. And of course, the secant is the reciprocal of cosine. So -1 over square root of 5 becomes negative radical 5 over 1. Similarly, the tangent is opposite over adjacent, 12 over -6. So the tangent is -2. Cotangent is the reciprocal. So that's the idea. You locate the point, draw your reference triangle, think about the reference angle to help you with adjacent, opposite, and hypotenuse. And you might have to calculate the length of the hypotenuse like I did here. Here's confirmation on Desmos. Oh, it turns out that the angle theta is actually 116.565 degrees. And the sine of that angle is 0.89, blah, 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 which happens to be 2 radical 5 over 5. Similarly for cosine, negative radical 5 over 5. So we've got confirmation on Desmos of all the exact values that were on board 1. I'll post a link to that Desmos graph in the answer so you can take a look. There you go. Hope that helped. If you have any questions, post a comment.